All right, guys, lesson 4.1 is on approximating with tangent lines and a little bit of applications of rates of change. So basically, here's what's going on. I have an example right here in number 1. It says if 2, -2 is a point on the graph, x squared plus y squared plus 2y equals 4. So that's this graph right here. That's this circle, okay? It wants me to find the y value when x is 2.1. So what we would have done in previous classes is you would have taken 2.1 and plugged it into this equation, which that alone is ugly because you're having to square a decimal. But on top of that, you still have a y squared and a y that you have to deal with when you're solving this equation. So trying to plug 2.1 into this equation is a mess. Sometimes we have functions that you're supposed to plug in an x value that the algebra, the arithmetic is really ugly, or sometimes for one reason or another, you can't plug that value in. All right. And what we do when that happens, one of the options that we can sometimes do is instead of plugging in 2.1, what I want to do is I want to, plugging in 2 would be a pretty easy number. Okay. I can plug in 2 and get this value, -2, really easily with that equation. And if I do that, using calculus, I can also find this tangent line. And what I want to do is, instead of plugging 2.1 into the original equation, I want to plug 2.1 into my tangent line. So I'm not going to find an exact value. I'm going to find what's called an approximation. And there's 2 different terms that they use. I have always used linear approximation. That's the term that I'm familiar with, that I've always seen. They introduced local linearization this year, and I'm not sure if that's just the author of the textbook's preference or if that's a term that he expects you to see in calculus. But either way, we can't plug 2.1 into the original function. So instead, we're going to pick a nice number, 2. We're going to make a tangent line, and we're going to plug 2.1 into the tangent line equation to approximate what the answer would be. So this makes the math a lot easier. So the first thing I need to do is find the equation of the tangent line. So to do that, I need a point and I need a slope. All right, I already have my point. It told me 2, -2 is my point. To find my slope, I'm going to take the x squared plus y squared plus 2y equals 4, and I'm going to find the derivative. So 2x plus 2y y prime plus 2y prime equals 0. I want to get y prime alone, so I'm going to minus 2x from both sides, and I get 2y y prime plus 2y prime equals -2x. And I'm going to factor out the y prime. So y prime times 2y plus 2 equals -2x. Divide by the 2y plus 2. And I know I'm going fast. That's why you have a pause button, so you can pause and copy things down when you need to, right? So y prime equals, on this side, those 2's all cancel. I have 2's on top and 2's on bottom, so I'm going to put negative, where'd my pen go? -x on top, and then y plus 1 on the bottom. So this is my derivative function, right? I need a slope at the point 2, -2. So what I want to do is I want to take y prime and evaluate at 2, -2 to get the slope. So that means on top, I get a -2. On the bottom, I get -2 plus 1. So that simplifies to be -2 over -1, which is just +2. So I have a slope of 2 at that point. So at this point right here, my slope is 2. Now I can write an equation of a tangent line. So y minus y1 equals m times x minus x1, just for a reminder. So y minus negative 2 equals 2 multiplied by x minus 2. And if I simplify this, I get y plus 2 equals 2x minus 4. And I'm going to go ahead and get y alone. So y equals 2x minus 6. So this is my equation of a tangent line. It's not my original equation, of course, but it's the equation of this tangent line that's really close to 2.1. So what it wants me to do, I'm going to go ahead and get rid of some of this work for a minute. What it wants me to do is use this equation, because I can plug 2.1 into that equation really easily. Now, I'm not going to get an exact answer, and I'm not looking for an exact answer. I'm looking for an approximation. If I needed an exact answer, this definitely wouldn't work, but I'm just looking for an approximate answer. So I'm going to take y equals 2, and I'm going to plug in 2.1 minus 6. So y equals 2, when do we want to distribute? No, that's not in parentheses. What am I doing? There we go. This is in parentheses. I'm like, wait, I got rid of the parentheses on purpose. 4.2 minus 6, so y equals negative 1.8. That is a lot easier than trying to plug 2.1 into the original equation and then solve a quadratic with ugly decimals, okay? So I can find my approximate, and what I should probably do is, instead of equal signs on these, I should probably use approximation signs. Because this equation, when I plug 2.1 into it, it is exactly 1.8, negative 1.8. But my answer in general is an approximation, so it would probably be a good idea not to use equal signs in that last step. And depending on who's grading the AP test, as long as your answer looks like this, you're probably okay. There are a couple graders that I've seen that if you didn't have the approximations on that step, you might lose a point. But you definitely have to have the approximation in the answer, all right? So it also wants me to figure out an approximation when x is 1.9. So I could say y is approximately, and I'm going to use that same equation, 2 times 1.9 minus 6. So it's approximately, 3.8 minus 6. So it's going to be approximately negative 1.2. All right. And again, we're just approximating. And a lot of times that's okay if you're just trying to get an idea. Obviously, this isn't going to work if you're looking for an exact answer. But it's going to work if you're looking for something close. All right. So number 2 is the same thing, except I don't have to do the derivative because it gives me information. It tells me that if f of 2 is 3, and that's just a point on some function. So if the function f gives me the value 2, 3, and the derivative at the point 2 is negative 2, use local linearization to approximate f of 2.1. So there's my slope. Well, nope, there's my slope. So I have a point, I have a slope. I can make my y, my tangent line, y minus y1 equals m times x minus x1. So y minus 3 equals negative 2 multiplied by x minus 2. So y minus 3 equals negative 2x plus 4. And I'm going to add 3 to both sides. So y equals negative 2x plus 7. This is the function I'm going to use to approximate my answer, right? So I'm going to say f of 2.01 is approximately negative 2 times 2.01 plus 7, which is approximately negative 4.02 plus 7, which is approximately what? Negative 2.98, because it's just under 3. So my value, again, at the end, that approximation is really important, and it would probably be a good idea to use it in that entire last step, not just the answer. Again, you might have a grader that doesn't care, but there's always the chance that you run into one that does. So, okay, enough linear approximations. Those absolutely will come up on the test. It's a very applicable way of using derivatives, and it's not really difficult. It's testing if you can use calculus to bypass doing a whole bunch of algebra. So it's a great application of derivatives, and it will show up on the test. So you're going to get a lot of those to practice over the next couple of months. So the second part of this assignment is just looking at some situations, looking at some graphs, and making, I guess, evaluating what different things mean. So the graph at the right models the rate of rainfall in inches per hour from midnight until 6 a.m. So if you notice going up the side here, this is the rate that rain is falling, and across the bottom is the time in hours after midnight. So it wants me to write a complete sentence to explain what point A on the graph represents. So what does this point right here represent? Well, first of all, that point is what? 3, 1. So 3 represents my hours, and 1 represents my Y value, which is my rate of rainfall. So to write what that point means, you could say something like 3 hours after midnight, the rate of rainfall, or you could say the rate that rain is falling. Doesn't matter, right? You're just describing, you're not going to get penalized for the words that you use or the context. You just got to make sure that you are explaining the point correctly. So 3 hours after midnight, the rate of rainfall is 1 inch per hour. That's the rate that the rain is falling. What is the slope of the graph between points A and B? So this time it wants to know what is the slope right here in between A and B. That's really easy, right? That's just, where's my pen? That's just 0. The slope is 0 in between A and B. Write a complete sentence to explain the meaning of that answer. All right, so in between point A and B, so between, what is that? 3 and 4 hours, between 3 and 4 hours, the rate of rainfall does not change, is one way that you could say that, right? The rate of the rainfall is staying the same from 3 to 4 hours after midnight. What is the slope of the graph between B and C? So in between B and C, it wants to know what is the slope of this graph. And remember, it's asking me to use units. So the slope is, I'm going over 1 hour. I'm going down 1 inch, right? Because this value right here is 1. So my slope is -1 inches per hour per hour. Because my units were already inches per hour, but now I'm finding the slope of inches per hour. So -1 inches per hour per hour. Write a complete sentence to explain the meaning of your answer. So you could say between 4 and 5 hours, the rate that the rainfall, that's weird. The rate that the rain is falling decreases by a rate of 1 inch per hour squared is one way you could say that. So between 4 and 5 hours, the rate that the rain is falling decreases by a rate of 1 inch per hour squared. So these graphs, as we move forward, you're going to get rates of rates, which can get a little bit confusing. So that's what the homework wants you to practice today, is translating what the graph is telling you, okay? It wants you to know the difference between if your y value is already a rate, what does the slope represent, right? The slope then represents the rate that your rate is changing, kind of like the acceleration, which can be a little bit confusing. So homework, that's it for today. Not a lot of examples because it's not, it's not a huge topic. Linear approximations are important. You're going to use them. They're going to show up on the test, but it's not a complicated process. You should be able to handle the math pretty easily. So on the homework, assignment 4.1, I don't think there is anything that you need to skip. I'm just browsing through really quick. I think you're good to do all the problems on 4.1. It is a little bit longer assignment because some of the story problems you're going to have to think through. It's not just going to give you the values. You're going to have to answer a couple questions and think through what's happening. And then, of course, there is some review problems. Not as many, though. If you look at this one, there's only, 10 review questions? There's not very many, so you should be able to handle that okay. If you have questions, email me. I will try to respond the best that I can.